Welcome back, student. Let's consider the next problem. A stone thrown vertically upward with an initial velocity reaches the height h before coming down. Show that the time taken to go up is the same as the time taken to come down. My dear student, here a situation is given to us. It is said that the stone, when thrown vertically upward, attains certain height, and from that height the stone is coming back on the surface of the earth. We have to show that the time taken by the stone to go up is equal to the time taken by the stone to come down on the surface of the earth. So let's try to prove it. Solution. Initial velocity is given u, height is given h. Now my dear student, these two information is given to us, but we also have the information regarding kinematical equations which we have studied in 9th standard. We are going to take the help of this kinematical equation to show that the time taken by a stone vertically upward to reach certain height of h is equal to the time taken by the stone to fall from that height on the surface of the earth. So V is equal to U plus AT is the first kinematical equation we have studied. The second kinematical equation which we have studied is equal to S is equal to UT plus half AT square. And the third kinematical equation we have studied is V square is equal to U square plus twice AS. Now my dear student, these are the three kinematical equations which we have already studied. We will take use of these three kinematical equations to show the time taken by an object to move vertically upward to a height h is equal for the stone falling down on the surface of the earth. So my dear student, first we will consider the stone thrown vertically upwards. Vertically upwards. Let's calculate the time taken for the stone when thrown vertically upward to attain the height h. So let T1 be the time taken by stone to reach the height h when thrown vertically upwards. Now my dear student, here we have to find the time and initial velocity is given. So we can take the use of the relationship between initial velocity and time. So we can take the use of the kinematical equation which is V is equal to U plus AT. My dear student, here we have considered the time taken for an object to reach at height when thrown vertically upward as T1. So this equation will become V is equal to U plus A T1. My dear student, here as the body is thrown vertically upward, acceleration due to gravity comes into play and A will be equal to G. And the value of final velocity will be 0. Here, as the thrown is thrown vertically upward, V will be equal to 0 and A will be equal to minus G. Now my dear student, try to understand the situation. What happens when a stone is thrown vertically upward? My dear student, the stone will have an initial velocity, and due to this initial velocity the stone will move vertically upward and attain certain height. The height is given to us, that is h. So the condition is clear. The initial velocity will be u, and when the stone will reach at a particular height h, what happens? The stone stop. And when the stone stop, what happens? The final velocity will be 0. So whenever an object is thrown vertically upward, it attains certain height, and at that height it stops, and then it is pulled back by the gravitational force and it starts coming down. And the initial velocity when the stone is thrown vertically upward is u, and at a certain height the stone stops and the final velocity will be 0. My dear student, here the moment of the stone is in the upward direction and the gravitational force of the earth is in downward direction. So acceleration due to gravity which is against the gravitational pull, and therefore the value of A will be considered as the value of G, that is acceleration due to gravity, and as it is moving against the gravitational force, so G will be minus G. So this information will take and put in the equation. So this equation will become 0 is equal to U plus, in place of A we will write minus G, and into T1 we will write it as it is. So 0 is equal to U plus minus minus G T1 we can write. My dear student, here we can keep U as it is, equation as it is, minus GT1 will take to the other side of the equation and it will become GT1. My dear student, here we are going to find the value of time, and therefore we can write T1 is equal to U upon G. Equation 1. Here, my dear student, we have find out the expression of T1, that is the time taken by an object when thrown vertically upward to attain height h. We have found out. What we have to prove? That this T1 will be equal to the time taken by the stone to form that particular height on the surface of the ground. So the time taken upward to attain certain height, from that height the time taken to the downwards will be equal. So this we have to show that the time taken by an object falling down will be equal to U by G. But my dear student, here time is given to us. Now we will find in this time the expression for height. Definitely we can find the height also. My dear student, here we have one more mathematical equation, that is V square is equal to U square plus twice AS. My dear student, here distance traveled by a body can be considered as height, as the body is moving vertically upward. So here, my dear student, we can write V is equal to 0, as we have already discussed. A will be equal to minus G, as we have already discussed, and S will be equal to height attained by the body. My dear student, we have calculated the time taken by a body to attain certain height when thrown vertically upward, which is T1. Now we will find the height attained by a body when the time T1 is taken. So this kinematical equation will become V, that is 0, is equal to U square, will write as it is, plus 2 will write as it is. A will get converted into G. Acceleration will become acceleration due to gravity, as the object is thrown vertically upward, and therefore in place of A we can write minus G, and S will be equal to height, and we'll write H as it is. 0 is equal to U square plus minus twice GH. Again, my dear student, we will keep U square as it is and the equal to sign as it is, and we will take minus twice GH to the other side of the equation, and this will become plus, and here it will become 2GH. My dear student, I have already told you that we are going to find height. Height is equal to U square upon twice G. My dear student, here we have found out the time taken by a body to move vertically upward, and we have also find out the height of the body when it takes time T1. Now, my dear student, here we have calculated the time and the height of the body when thrown vertically upward. Now, my dear student, we have to calculate the time taken by the body to fall from particular height on the surface of the earth, and show that the time taken to move upward and the time taken to come on the surface of the earth is equal. So one more kinematical equation is there, my dear student, when the body is coming down on the surface of the earth. So when the body is, I will write stone. So when the stone is falling on the surface of the earth, let us consider T2 as the time taken by the stone to reach on the surface of the earth from the height h. So my dear student, we will take use of another kinematical equation, that is S is equal to ut plus half a t square. Now my dear student, here time we have considered, and this time we have considered as t2. So this equation will be s is equal to ut plus half a t2 square. Now my dear student, here the body is falling vertically downwards from a certain height. As the body is falling vertically downwards, acceleration will become acceleration due to gravity. My dear student, when the body is falling from certain height, the initial velocity of the body is 0 because at certain height the body is at rest. So we can write u is equal to 0, a is equal to g. My dear student, here when the body is falling down, there is an acceleration in the body, and this acceleration in the body is due to gravitational force, and therefore the acceleration which comes in play is acceleration due to gravity, and therefore a will get converted to g. The direction of the gravitational force and the displacement is same, so g will have a positive value. So my dear student, let's consider this equation. S is equal to ut plus half at2 square. This equation will become S is equal to u is 0 into t plus half, in place of a will write g, and t2 square we can write. Now my dear student, here s is equal to h, so we can write s is equal to h. So h is equal to 0 plus half g t2 square. So my dear student, here we can write h is equal to half g t2 square. So my dear student, we are considering the time taken for the object or a body to fall on the ground from a certain height. So we are here finding the value of t2. So what we will do, we will take 2 to the other side of the equation. It will be twice h is equal to g t2 square. So t2 square will keep as it is equal to also will keep as it is, twice h will keep as it is, and g, which is in multiplication, will take it to the other side of the equation, it will go in denominator. So here my dear student, we have got a mathematical equation, that is t2 square is equal to twice h upon g. So here we get one more equation. We will give it as equation number 3. Now my dear student, the same equation we can write in this way. t2 square is equal to twice h divided by g. My dear student, here we have found out the value of h. So we will put the value of h in equation number 3. Put the value of h from equation 2 in equation 3, we get t2 square is equal to 2 into u square upon twice g divided by g. Now my dear student, here we have to show that T1 is equal to T2. So what we can do? T2 square is equal to 2 into U square upon twice G. This is division. So this division we can convert it into multiplication. So we can take reciprocal. So G can be written as 1 by G. Now my dear student, here 2 will get cancelled. We get T2 square is equal to U square upon G into G square. Now my dear student, we can write T2 is equal to under root U square upon G square. So T2 will be equal to U upon G. Equation 4. Now my dear student, if you observe equation 1 and equation 4, you will find T1 and T2 is U by G and is U by G. So from equation 1 and 4, equation 1 and 4, we can write T1 is equal to T2. Hence, we have proved that when a stone thrown vertically upward with an initial velocity u reaches the height h before coming down is equal, and therefore the time taken to go up is the same as the time to come down, is proved by us. Thank you very much. Let's study the next problem. Find the magnitude of acceleration due to gravity at the surface of the earth. My dear student, here we have to find out the magnitude of acceleration due to gravity at the surface of the earth. Mass of the earth is given and radius of the earth is given. Let's try to solve the problem. Mass of the earth is given, that is capital M is equal to 6 into 10 to the power 24 kg. Radius of the earth is given, that is capital R is equal to 6400 kilometer. My dear student, here the kilometer we have to convert it into meter. Kilometer. 1 kilometer is equal to 1000 meter. So 6400 kilometer will be x. So my dear student, here we will take cross multiplication. So x is equal to 6400 into 1000. X is equal to 64 into 100 into 1000. X is equal to 64 into 10 square into 1000. X is equal to 64 into 10 to the power 2 plus 3 we can write. So x is equal to 64 into 10 to the power 5. My dear student, here we have to convert it into scientific notation, and therefore x is equal to 6.4 into 10 to the power 6 we can write. My dear student, here we have converted the radius of the earth from kilometer to meter, and therefore r is equal to radius of the earth, and it is 6.4 into 10 to the power 6 meter. The value of capital G is known to us, that is gravitational constant is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Acceleration due to gravity is asked to us. The formula of acceleration due to gravity is G is equal to capital G into capital M upon R square. Let's put the value. G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square into the value of mass of the earth is given, that is 6 into 10 to the power 24 kg divided by capital R, and that we have found in meter, and it is 6.4 into 10 to the power 6 meter whole square. G is equal to 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 divided by 6.4 into 10 to the power 6 whole square. Now my dear student, here we will try to remove the bracket. G is equal to 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24, and this 6.4 into 10 to the power 6 whole square we can write in this way: 6.4 into 6.4 into 10 to the power 6 into 10 to the power 6. Now my dear student, in order to make the calculation easy, we will arrange the values in such a way that we will take 10 to the power notation to the one side and make the step simple. G is equal to 6.67 into 6 into 10 to the power 24 into 10 to the power minus 11 upon 6.4 into 6.4 into 10 to the power 6 plus 6 we can write. G is equal to 6.67 into 6 into 10 to the power 24 minus 11 divided by 6.4 into 6.4 into 10 to the power 6 plus 6 is equal to 12 we can write. G is equal to 6.67 into 6 into 10 to the power 24 minus 11 we get 13 divided by 6.4 into 6.4 into 10 to the power 12. Now my dear student, here 10 to the power 12 is in denominator, we can take it in numerator, and the same we can do in this way. 6.67 into 6 into 10 to the power 13 divided by 6.4 into 6.4 10 to the power 12 is in denominator, we can take it in numerator, and therefore we can write 6.67 into 6 into 10 to the power 13 minus 12. G is equal to 6.67 into 6 into 10 to the power 1 upon 6.4 into 6.4. My dear student, here if you study this step, we have to remove the point, and the point we have to remove from the numerator and denominator, and we have to remove 2 digits from the point. So 6.67, so this point we have to remove, so we have to remove the point after and take the 2 digits, so we can directly write here like this. G is equal to 667 into 6 into 10 upon 64 into 64. So 2 digit we have to remove from the numerator and 2 digit we have to remove from the denominator, so we can write it as I have written on the blackboard. Here my dear student, the calculation has become very easy, and if we multiply 667 into 6, we get G is equal to 4002 into 10, and 64 into 64 we get 4096. Now my dear student, G is equal to 4002 into 10, we get 40020 divided by 4096. And my dear student, if we divide 40020 by 4096, we get 9.77 meter per second, the value of G. So my dear student, we can write the magnitude of the acceleration due to gravity at the surface of the earth is 9.77 meter per second square. This is the answer. Let's study the next problem.